Hello and welcome to this special little tutorial on Newman projections. Newman projections are always a difficult topic in this class because it's one of the first things, the first topics that you really need to be using your mind's eye when you're looking at molecules and rotating them around in free space. So what do I mean by that? I mean, let's say you take a 2D representation of a molecule. We'll just do this. So this is butane, right? C4H10. And if we were to draw this in wedge and dash notation, let's see, we'll leave this blue and I don't know, we'll use a green. No, we'll make it red. All right, so if we were to use wedge and dash notation, let's make the wedges red. So here's a hydrogen on a wedge bond. And here's another hydrogen on a wedge bond. And then you have some hydrogens on a dash as well, right? And this is to show us that the wedges are coming towards the viewer and the dashes are going away from the viewer, trying to show some 3D aspects of the structure that we've drawn there. And Newman projections work because what we're trying to do is we are trying to show in 3D space that the molecule in question is in fact, it looks different depending on which carbon you're looking at relative to the other. So what does that mean? So let's say, for instance, we were going to look at one of these carbons. Let's say it is the carbon on the right here. So we're going to make our viewing point down this carbon here, right? So that means that when we draw the Newman projection, we're going to draw it like this. So looking at this molecule now, the dash hydrogen in front is here. The wedge hydrogen is here on the left. And the carbon, the CH3 that was pointed down is still pointed down here. And in the back, what we have is the carbon pointed up now. And the wedge hydrogen pointed to the left on the same side as the other wedge hydrogen. Oh, sorry. As the other wedge hydrogen. And the dash hydrogen also on the same side as the other dash hydrogen. Make that the same color. Feels better to have the same color there. Okay. So that's how this molecule would look if you were drawing a Newman projection from that carbon. However, there's another carbon that we could look at as a Newman projection, right? Let's say instead we look at this carbon. And now when we look at this carbon from this side, we might have a different set of circumstances, right? Because now, looking at this, the dash hydrogen is going to be on the left. The wedge hydrogen is going to be on the right. Oops. Right is the direction, not the atom. There we are. And the carbon from the butane is going to be pointed up this time in the front, will it not? Okay, and in the back, the CH3 points down. The wedge hydrogen is also pointed to the right, and the dash hydrogen is pointed to the left. That's because in looking at each of these Newman projections, you could imagine that we have rotated the molecule different directions in order to obtain a different method of viewing this molecule. I know it's hard to see in 2 dimensions, so what I've done for you is I have made a small model to hopefully try and illustrate this point for you. All right, so what we have here is a 3D model version of that 2D molecule that I drew, butane. And if you see, the black lines here represent the carbon-carbon bonds, and the red lines, or the red bonds, represent the dash, or the wedges, just like we have in the drawing. And the blue represents the dash bonds that we have in this molecule as well. All right, so let's say that we want to draw a Newman, or look at this using a Newman projection in this carbon. So that means this carbon here is going to come towards you, towards the front, and we're going to look down this carbon-carbon bond, okay? So in doing that, I'm not super good at this. We're going to give it a shot, though. There we are. Okay. Oh, this is challenging. There we go. All right, so here now, you can see in our little Newman projection that looking at that carbon, the dashes are both on the same side, the blue protons, right? And the red ones are all on the same side as well. Perhaps you can't see that. Maybe I should turn my screen. I'll just stop sharing here. We'll try this again. There we are. So the blue ones are the dashes, and the red ones are the wedges, and the black ones, the black bonds here, are the carbon-carbon single bonds that are in the plane. So again, if we were to look at this carbon as our Newman projection, looking, down this way here, then what we're going to do is turn the molecule this way. There we are. So now what you see is that the black carbon bonds point up and down, as we saw before, and the red bonds, sorry, this is not as easy to, there we go. Yeah, there we go. And the red bonds there are the wedges, while the blue are the dashes, because we rotated this way to make that Newman projection. And you could similarly rotate the other way. Oop, losing it. There we are. To get the dashes on the other side, the blue bonds there, and the wedges on the other side as well, because we rotated from this way. So this is the kind of manipulations that you need to do in your mind to be able to look at a Newman projection and be able to draw molecules that are more complicated than this in 3D space, right? This is why having a molecular models kit can help you. You don't have to have it because you could certainly envision these transformations happening, but it could be helpful to do. In fact, this type of molecular models kit you can reproduce simply by using toothpicks and marshmallows at your house if that's all you have. That's what I did in undergrad, and it served me well. Because essentially, you just need something that is going to be able to to be detached, like a toothpick, from other things, like a marshmallow. And this has been a little tutorial on Newman projections.